Hello, I'm ETarte, math teacher. Some of the geometry students whom I tutor are currently studying perpendicular bisectors of the sides of a triangle. Here's a triangle, and I have indicated the perpendicular bisectors in red. Each one of them makes right angles with its side, and each one of them splits its side into two equal parts. That's what perpendicular bisectors do. Their teachers in the classroom have been telling them correctly that the three perpendicular bisectors of the sides of any triangle all meet at the same point. But as far as I know, the teachers never explain why that is true. They just hurriedly present the fact and then go on. In this video, I'm going to ask you, why is that true? These geometry students have studied that if you have a line with 2 points given on it, having coordinates x1, y1 and x2, y2, then the slope of that line is the fraction y2 minus y1 over x2 minus x1. They've also studied that if you consider the segment AB, that is going from A to B but not beyond, the midpoint of that segment with those coordinates at the ends is x1 plus x2 over 2 and y1 plus y2 over 2. Those are the coordinates of the midpoint of that segment. They've also studied that if you have a line with slope m and a point on the line has coordinates x1, y1, then you can write this equation of the line. It's called the point-slope form of the equation of a line. Y minus y1 equals m times x minus x1. Well, those are the main things that a geometry student needs to know in order to show or prove that the perpendicular bisectors of the three sides of any triangle all meet at one point. So suppose this triangle is placed in the coordinate plane with one of its sides along the x-axis from 0, 0 out to the right. And I will call this vertex, well, I could call it A0, but to make it more friendly, I'm going to call it 2A0. And this top vertex, I could call it BC, but to make it more friendly, I'm calling its coordinates 2B, 2C. So my question is, using this setup, can you show or prove that the three perpendicular bisectors of the three sides of the triangle all meet at the same point? If you can show that and you would like to show me your proof, I'd be delighted to see it. You can show it to me in a personal message at my profile page, or I'm willing to take your word for it. And if you do it successfully, I'd be happy to give you a prize if you want it. The prize that I offer is what I call a 6-pack. It's an audio folder consisting of 6 piano selections from my extensive YouTube collection. If you would like the prize, please request it and include your email address. In any event, I hope that if you work on this challenge, it will give you mental stimulation and pleasure. Thank you for watching.